Now we got to know about how the registers are organized in a RISC-V architecture. So let's understand how these registers are actually organized by debugging practice. What you can see is the window in TRACE32 debugging program. This window is instruction window. And another window is a register window. And please take a look at this. And this is indicating the value of any of the general purpose register in a RISC-V architecture. Please take a look at this. Name of the register start from X0, X1, X2, X3, X4. As you can see, the general purpose register has its own value. So this is a way to specify the register in RISC-V architecture. This can be called architectural name. What I mean is, please take a look at this. X1, X2, X3, X4. This is a way to specify the register based on architectural name. But as for X1 register, this can be called the RA register. RA register is return address register. As for X2 register, this register can be called SP register. How to specify the register based on ABI name is depending on the calling convention. Because X1 register is used in the calling convention and X2 register also used in calling convention. Uses of X1 register is RA register because from another perspective, X1 register is the link register because if you run JAR instruction in RISC-V architecture, return address is updated to the X1 register. I can say that RISC-V define those kind of register based on architecture name. Also, another way to specify register is based on ABI name. ABI name follow the calling convention. So now, and we will look at the value of general purpose register in more detail by changing its mode. Another interesting working will be change the mode to see the general purpose register. So I'm going to use the command that is supported by TRACE32 debugger. So I will paste it onto this terminal. Please take a look at this. The register is displayed based on the ABI name. Please take a look at this ABI name. RA register, SP register, GP register. So as you can see, the first view of the register window is based on architecture name, but it changed from architecture name to the ABI name. So I will roll back to the original state to display general purpose register in architecture format. For this, I should use this command. So after I enter this command, please pay attention to this window. 2, 3, 1, 2, 3. Please take a look at this. X1 register, X2 register, X3 register. The way to specify the general purpose register is updated based on architecture name. Let me change the convention to specify the register based on the ABI name. The RA, SP, GP, TP, okay? So whenever you have opportunity to view or look at general purpose register, and please note that there are two ways to display the register, general purpose register, in RISC-V architecture. Now that you got to know about the value of the register, let's continue debugging. So this window is about instruction window. Instruction window is consisting of the two components. The first one is the address and second one is assembly instruction. And as you can see, every instruction has the general purpose register. As you know, input of any of the instruction and output of any of the assembly instruction are general purpose register. So I'm going to execute each instruction to see if what's going to happen. So I'm going to rearrange the position of each window, okay, to see the value of the general purpose register. So here we go. I'm going to run this instruction, and as you can see, the result of this instruction, it can be identified, and as you can see in this register window. Since RISC-V architecture follow RISC design philosophy, most of the instruction is together with the any of general purpose register. As you can see, RISC IP design follow load and store operation. As you can see, and most of the instruction are organized with any of the general purpose register. As for this instruction, the destination register is A3 register. As for this register, this instruction, A4 register is one of the general purpose register. So activity of debugging is to check the value of any of the general purpose register before, after this assembly instruction. Let's analyze this assembly instruction. As you can see, input of this instruction is A3 register. So we have to check the value of A3 register. So here we go. I will execute this instruction. The value of the A3 register is updated. So this is the activity of debugging. So I'm going to run another instruction. As for add I assembly instruction, value of A4 will be updated. So please take a look at this. This register is also updated. So understanding of how these registers are actually used in RISC-V architecture at the software level, it is very important task. And another type of register in the RISC-V architecture is control and status register. But most of the debugger does not support the window of CSR register, but TRACE32 debugger allow us to see the value of CSR register. For better understanding, let's navigate menu from now on. I will click the view menu and I will go to the peripheral. The first sub menu in the window is CSR. If I click this button and sub menu appear like this. Among them, I will choose the supervisor trap handling, supervisor protection, and translation. These are the CSR register control the status register in the RISC-V architectures. And those values can be identified using the special feature supported in the 332 debugging program. The further analysis will be done in the next lecture.